Hello, and welcome to another episode of Let's Make It. And this week, I am running a little bit behind. I didn't really get a chance to get much set up, but when I got home tonight, I worked on something, and I'm actually going to put together a segment. And Bob's working on a secret project as well. Right, Bob?
Well, not so secret.
So we're working on a project. He's working on a project for next week. So we'll just bring it to you next week. But basically, he wants to show a little bit more about some of the XP. We've had some user questions or viewer questions, and he wants to cover that. So he didn't quite make it this week. He's like me. He's just a busy guy.
Well, yeah, too busy sometimes.
Yeah, that's been me. So I'm trying to get this switcher out, and we decided to make some changes to it last minute. So it's just been keeping me busy because we're trying to get well, we're not going to use Kickstarter now. We're going to use Indiegogo. But we're trying to get that campaign set up. So we decided to go to bigger buttons and 3 color buttons versus 2 color buttons. So that was a last minute change, which meant some redesign of PC boards and stuff. So that's all in progress. But it just keeps me busy.
Yeah, and indeed it does.
So this week I have a fairly quick project. It's going to cover what we mentioned before about the web server. We're going to take it one step farther, and we're actually going to control an LED, an RGB LED, and a servo via the web interface. So it will show you what you can do to control things for projects over the web versus having physical buttons. So we'll do that in the second segment. We're going to start doing some things. We've had some requests to do some Raspberry Pi projects. Basically take what we've done on the Arduino and do them in Raspberry Pi. So we're going to go back through some of the things we've done in the past and do that on Raspberry Pi as well. And plus, I started playing with this. I've just got it booted, basically, and I want to take it to the next step and play with it a little bit more. But this is the BeagleBone Black. And what I played with so far is pretty interesting. It's a little bit faster than an Arduino. Actually, it's quite a bit faster than the Arduino. So I also played with an Arduino Duo a little bit this past week. It seems more limited in some ways, but faster and better in other ways. So it doesn't have any kind of EEPROM storage, which is something that for what I was trying to use it for, I do need. But its CPU is considerably faster than like a Mega. So I never realized that. I always consider it to be the lower end of that size board from Arduino, but it ends up being, it's a lot faster, a lot more memory. So have you ever played with one of those, Bob?
No, I haven't, but it is, yeah, I couldn't remember the spec on it, right? Yeah, it's running at 84 megahertz.
Right.
Rather than the 16 that a regular.
Right, and look at the amount of RAM that it has compared to the other ones.
Says 512.
The other ones are 256, so it has double of that.
Double the RAM.
The program space is 4 times the size, I think. The ARAM or PRAM?
96.
96.
3 times.
Right, 3 times. Okay. So it's considerably bigger as far as power goes. It's only missing the EEPROM. The other thing, it's 3.3 volts, so you have to kind of get used to doing things in 3.3 volts versus 5 volts. If you put 5 volts into it, you're gonna mess it up. So,
yeah, it's also 32-bit rather than 8-bit.
Right, exactly. So it does 4 times the calculations in one clock cycle.
Right.
So I think that's probably the difference in speed that's the most noticeable is, doing 4 times the amount of work. So, but the BeagleBone is a very similarly spec'd, so that's why I'm kind of interested to play with it a little bit. Actually, there's a lot more stuff on this BeagleBone than what there is on an Arduino. It's very interesting. If you look at this, actually, I can go to I don't know if you can see it in the overhead or not. There are surface mount parts on both sides of this board, and a ton of them. Look how small they are. And then on this side, too, the thing's just full of parts. So it's a very tight design. There's lots of parts that are on it. So it's very interesting. I always like playing with new stuff. So just finding the time to play with that kind of stuff.
Yeah, sometimes it's a little tough to play.
Yeah.
But
yep. Okay, so
in this case, get demos.
Yeah.
For the show.
So we have Jim in the chat room tonight. He's asking some questions. Let me. He says my audio is muted. Is it better now, Jim? Can you hear me now? You should be able to hear me. So I don't know. We'll keep going, assuming, because I see it going out to the stream, so I'm assuming that I'm okay. So I'll keep it going. Just want to remind you that we do this show live every Monday night with all the problems like you're seeing tonight. We got a late start because of some problems in the studio mostly. Also, my project was not working right, but we're still having some technical issues around the studio. And it always happens right before a show. So don't know what the issue is with that. We're still working through some of those changes. I'm almost regretting going to Windows, but I don't want to say that yet. So anyways, we're here every Monday night at 9 p.m. We generally start at 9 p.m. We're a little late today, getting started a little bit late, but this will be a little bit shorter show than normal because we really only have one sketch to go through and show you some web control of physical things. So we're going to walk through here shortly. If you're not watching us live, you can get us on demand either on our website at tech-zen.tv, or you can go out to youtube.com/techzentv and you can get our stuff as well. We're also available in all the podcast locations, dog catcher, whatever you used, or Android or Apple or PC, whatever, iTunes, you name it, we're there. We also have a Roku app. If you have a Roku, you can download our app and you can watch our stuff right there on the Roku, right on the big screen on your TV as well. All right, so we're going to take a real quick break here, and we'll be back. And when we come back, we're going to go through, I kind of gave you a little bit of a preview there a second ago. It's basically the same board we used when we did the web, but we have some physical things we're going to control via the web interface when we come back.
You work hard for your business. Your website should too. No matter what industry you're in, select your customizable high-quality design with professionally written content and graphic elements created for your business. Make changes online whenever you like. Switch your background color, page layout, and text anytime. Add your pictures and logo. Upgrade your website with useful one-in-one web apps. And integrate social media. Upload your photo albums and embed videos. With one click, optimize your website for viewing on mobile devices. Choose your free domain, or you can easily transfer an existing one. Thanks to One-in-One's SEO tools, customers can find you everywhere. One-in-One My Website, a professional website created by you.
When you open up an Audible audiobook, it opens up your imagination. Enjoy a steamy romance while ironing the sheets. Discover an historic battle while battling the bulge at the gym. Visit audible.com/freebooks now to try 2 books absolutely free. Get caught up in a whodunit during a do-it-yourself project. Listen anytime, anywhere with the Audible mobile app. When you're out for a walk, learn how to climb the corporate ladder. Or bring a little magic to your minivan with a fantasy novel. With over 100,000 titles, Audible is an amazing experience that you can now try absolutely free. And just like our books, there's no binding. Our great listen guarantee lets you exchange a title you don't like for another. No questions asked. Visit audible.com/freebooks to download 2 books of your choice right now.
Okay, we're back, and before the break, we did a little teaser here. We're going to walk through it a little bit more, but we're going to talk about how you can control physical things from a web interface using an Arduino. So we're going to hop over here, and as mentioned before, we basically have an Arduino Uno with an Ethernet shield. It's the exact same one we did when we did the card read, and also we did the other Ethernet web server show. And then you have this little breadboard here. You see the blue LED right here. And you have an RGB LED right here and a servo. And what I'm going to show you is how from a web page you can make these things do different things. So let's show you the web page real quick. All right, so here is the web interface that we have created this time. Still pretty simple, a single page. And you see I have a web control for control pins, and I'm going to turn off and on what is pin 13. And then I also have the ability to control a servo. Right here I can say where I want the position to be. And then I can also turn on the RGB LED in different variations of colors based on from 0 to 255 for red, green, or blue. So before I go into this, I want to walk through the code. It's actually a little bit more complicated because it's a little bit longer, but we'll walk through it. And it'll look fairly familiar from the web episode. So this is basically a number of different shows kind of wrapped up into one, because we have talked about servos, we talked about the RGB and the pulse width modulation before, and we've covered pins and turning LEDs on and off quite a bit actually. So, and then we just covered the web server. So we're going to combine all that stuff into one. So we start at the top, and I have to include the SPI, Ethernet, and web server just for the web server alone. The only other library I really need is the servo.h, because that's what we need to control the servo. And then we define our MAC address and our IP address right here, like we did in the previous show. And we want our web server to start on port 80 and no prefix. So basically it's going to be at the top level of the web server. And coming down, I create a servo object called myServo, and then I'm going to define where I have the servo. Servo pin is equal to 9. And this particular servo is a little different than the ones I used before. And I found out through experimenting this evening that it doesn't like going below 13. If you get below 13, it starts making this noise. And the farther down you go, it gets lower and lower and lower. So, and then we have the maximum amount of 175, and that's what the old one was. I didn't see if I could go higher than 175 with this one. It's very possible that I could have. And then the current server position. Now you're going to see here, I should probably make this 13. So that starts at 13. And then we're going to come down, and now we're going to define the red, green, and blue values. So that's weird. I don't know what that's doing there. I'll get rid of this. We define our default colors of our red, green, and blue as 25. And what the C is the current value. And the reason we have current servo and current red, green, or blue is I want to show you on the screen what the current value is. And I'm not doing that with the LED, and I'm going to show you why as we go down here a little bit farther. So we have connected to pins 3, 5, and 6, the pins of red, green, and blue, right here, 3, 5, and 6. So that's basically our definitions for this app. And now we're going to come down and define our default view, so kind of we did 2 weeks ago. And we create our header, and there's the Arduino web control title right here, and we're defining our font sizes. And then we are going to send out, when we get to the default page, we're going to send out success, where we're going to send out the 200 connect code. Then we're going to print this header right here. And then we're going to print out the actual web page. And this is where it gets a little bit longer. So at the very top, we're saying this is the title of the web page is web control. And then we're going to print out the H2 of control pins. And then we're going to do H3, which is pin 13. And then we create a form. And in this form, this is why there is no current state for the LED, is first thing we do is we look at the state of the LED on pin 2. And we say, okay, is it on or is it off? And if it is on, then we're going to print out to the web page a submit button that has the value of off for pin 13. If the pin is actually off, then it's going to come down to this else statement right here, and it's going to say, here's a submit button with the value of on to pin 13. And then we close the form. So one of the things you're going to notice in this demonstration is we have multiple forms. And we do that so that we don't change the value of what's being submitted for the other sections. We could have created one big form, but it's just a little bit more efficient to do it this way. So we're going to close the form out right here. Then we're going to come down and we're going to print out servo position. And this is where we're going to tell the servo how we want it to be, or where we want it to be placed based on its value of the range of the servo. So we create another form right here, and it goes to the exact same thing /form. And we have one text value, and it's basically the name of it's called servo. And we're going to print out in that field the current location of the servo. And that is done by us. So the current servo position I set to 12 or 17, I'm sorry, 17. at the top. And if you change that, I'm going to change that value so I know where your current value is, so I can print it out to the web page so you know where you're at. And then we close out that form as well. And then we get into the RGB LEDs, and this is 3 input fields. We have 1 for each color. Again, we have our form, and then we define 3 text values, and here we go, input type is equal to text. And you see the value here, I'm putting C red, C green, and C blue. That's so I print to the web page what the current values are for red, green, and blue. And you see the names of the fields are red, green, and then here is blue. And then there's another submit button right there. And we close that form, and then we close the page out. So we come down, here's our default command, which we talked about in the last episode. We can, if you want more details about how to do the web page in the web server, listen to episode 49 where we cover that. I'm not going to go into detail how to set up the web server on this episode. And then we come down, and here's our form command, and we're looking for, again, make sure it's a post. Here's our name and our values right here. We're going to read the post parameters up to 16 for the name, up to 16 for the value. And you see right here, I create two string variables. One I'm called name, one I'm called value. And that's because I want to do some functions on these later using the string class. So we basically are converting the character array of name into a string class of name, and the same thing with value. We're converting into a string class of value. So our first thing we do is we look for the pin 13. And with pin 13, if I receive the off, so basically the submit button that's named off comes to me, I'm going to digitally write to pin 2. Okay, that's right. I moved it from pin 13 to pin 2 because of pin 13 was having issues. So it's actually pin 2. I should probably rename this, and I'll do that for the final sketch that goes to the website. But it's actually pin 2. I'm going to turn it off. But if I don't get the off command, it has to be the on command, because that's the only other thing I have with pin 13. So then I'm going to go ahead and digitally write to pin 2 and turn it on so it's true. And then we're going to look for servo. And right here I'm converting the text to integer. So I take the value, the character array of value, and I convert it to an integer into a variable called servo position or servo pos. And then I'm going to check and make sure that the value that was entered is, well, if I'm going to check, if it's less than the minimum servo, which is in my case is 17, I'm going to set it to equal to the minimum. And you're going to see that in the web page. I'm going to show you that when I put in a value that's out of range, it's going to fix itself. And the same thing goes with if it's out of position on the other direction. So if you put in a number that's bigger than the maximum position, it's going to take it to the maximum position, and you'll see that again. And then I write to the servo and tell it where I want it to go in servo position. And then I store where the current position is in current servo, so I can display it back on the web page when it prints back out again. And then I come down and I check for a red, and I do the same thing. I take the number that comes in, and that's in the value character array, and convert it to an integer. And if it's less than 0, that doesn't make any sense, so we're going to make sure it's equal to 0. And the maximum value you can have output is 255. So if it's greater than 255, we're going to make it equal to 255. That's full brightness at 255. And then I'm going to do an analog write to the red pin with that color number. Now you got to remember LEDs are controlled, brightness is controlled by pulse width modulation. So these are all on pulse width modulation capable pins. And when you write this number out, it sets the duty cycle for the pulse width modulation. And then I set the C red equal to the current color number, because that's the last number that we got in from red. And I do this against the exact same thing again for green and for blue right here. And then at the very end, I say, go back to the top page. And if you don't send me anything to the form, I'm going to send you back to the default command by default. And then in setup, there's a few things down here. We have to set our pin modes. And like I said, now I'm using pin 2 instead of 13. And I set the output. I set my red, green, and blue pins to output. I attach my servo to pin, whatever servo pin is, which is actually 9 in this case. I start up my Ethernet, start up the web server, and then I add my 2 default commands, or my default command and my form command. So if you look back at episode 39, we actually had an additional page here that we demonstrated, but we're just in this case, I don't need an additional form. So it's just 2 items in that list. And then in the loop, all we do is process the connection. So we're doing all this in 223 lines of code. And that includes a very lengthy thing at the top that gives you details about the code itself. So let's go ahead and I'm going to hop over to the overhead, and let me get back over to the web page. And let's see if I can mirror this or not. Oops, wrong one. You can't see the computer, so we're just gonna go right to the overhead. So this is I'm gonna hit on the on button on the web page, and it's turn the blue LED on. So here we go. We're gonna click. I clicked, and there it's on. So if we come back over and we look at the web page right here, it's off. So the button says off right now because it's turned on. So if we go and we click it to on, so now it says that it's off. So hit the button, we'll turn it on. And we go back over and we look, we see that the LED is off. So I'm going to change the servo position to, let's say 200, which is above the value. So there the servo moved to 175. So if we go back over and we look, you see right here our value is 175, and I actually put in 200. So our checking code that we had in there, you see, puts it back to 175. Same thing goes if I put 2 in here, which is below 17. It's going to, you heard it move, make it 13. And actually, you may be able to hear the servo still fighting itself. So let's go to 14. Maybe 13 wasn't far enough. Still doing it. Let's make it 15. It's still fighting. I can feel it. I actually have my hand on it right now. So let's see, 16. Still doing it. I thought it was 17 was where yeah. I know it's still doing a little bit, but it's better. Try 30 once and see what happens. It definitely is not making noise now. All right, so we're back. It's working. I don't know what happened there. But if let's go back and look at it. I'm going to do the RGBs now. So right now they're for 25, 25, and 25. When I hit submit, you see the LED that comes on. But if I want it to be like red, I can make the red, for example, 255. Press enter. There's red. Unfortunately, with this LED, I don't know. Right now there's no red. And let me turn off the blue. The green seems to be very weak to me. So there's green. So there's full green, 255. If I turn on full red, it just walks over the green. You can't even tell what's even there. So let me turn off the green. I couldn't see any difference. Now, if I turn the blue on, I can tend to see the difference. Oh no, that I can't. It's like red on this thing is super bright. Let me turn off the red. So there's blue, and only blue. There's blue and green. So if you watch on the webpage, I'm just changing these values. So if I turn them all on full brightness, and we go look at it, you see red is very, very bright. I'm going to go ahead and turn off the green and the blue. And I couldn't tell any difference. You can't even tell the red and the green and the blue are there because the red's so bright. So I don't know why that is. I haven't looked at the specs on this particular LED because there's green, so we can see a little bit of red in there. Red's down to 30 now, and there's red at 50. There's red at 90. So you can see red starts taking over. Green's at full brightness, and red's starting to take over already at 90. We can turn on the blue. So yeah, don't know why. There's every LED, RGB LED has different specs to it, and this must be one that's very red facing. All right, so again, here's the servo. And see, that's at the high of 175, and let's go down to 17 and see if it makes the noise it did before. Is it still doing it? No, it's not. It's not kicking like it was before. So I think 17 was the number where I thought it was. It's still not doing it. It's still very quiet. It's starting to do it right there. So just vibrating a little bit. But you can see from a simple web interface, you can control all kinds of things. If you could add a relay to the LEDs and control all kinds of things, as in addition to getting status of things. So we kind of showed you last week about outputting things or data from like a sensor. But here, if you look at the code, I'm actually outputting this right here, this on and off. You see how it changes based on the state of another pin. So if we come in here and we look down here in the source code, right here I'm looking at the pin state and I'm putting out the different value depending on the state of the pin. So you can do all this stuff via a web interface. It'd be think of a web controller for your garage door. You look at the web interface and you say, hey, the garage door is still open. You click the button and it closes your garage door. So that's the type of thing you can control using a web interface like this. So, and tonight obviously was a very rough night technology-wise for us. So, and we only have one thing. So Bob did something. Do you want to walk through it real quick, Bob, and explain what you're going to do next week? Just give him a tease. How's that?
Well, yeah, I got the tease. Let me switch cameras. This is the tease for next week, and what I've got is a Arduino with a XB radio connected to an LCD screen, and then I have this 25 key keypad, and if I press a key, I get something on the screen, and ultimately what I'm going to do is use the radio to transmit data that that is connected to another Arduino that is running and I actually, believe it or not, I still had the breadboard put together when we did that 14-segment multiplexing episode. I think it was somewhere around episode 30.
Yeah, it's been a while.
28, 30, somewhere around in there. I still have that display on the breadboard. I never took it apart, and I'm going to use that. And this is actually based on a number of viewers who have questioned how do you transmit data back and forth and have a remote display. So I've probably got 5 or 6 people that have asked me variations on that question, and this is going to answer, I hope, all of them. So, but I've got some smaller videos that I'll show next week. That essentially one of them is nothing more than blink over the radio, the standard hello world kind of programming for a microcontroller. So, and that's all it does, is it just blinks the LED on the other display. So I've actually got a couple videos and several variations of the code, and we'll kind of step through it. But this will be a episode where we put the pieces together of different episodes that we've had over the last 6 months.
So the Zigbee or the XBs you have, do they have the antenna on top, or are they the ones that are flat on top?
They're the small, they're actually small antennas, and I don't know if you can see it. It's actually right here. If you can, let me move you see the...
Yeah, so you have a little wire on top of it, right?
Little wire antenna.
Yeah, so you had the one that had a little square on top of it. So I don't know how far they went. I was kind of curious how far yours would go apart before they stopped working.
According to the spec, these are supposed to be reliable at full speed, up to 30 meters indoors.
That's it, 30 meters? I thought
30 meters indoors in a building.
Okay.
Outdoors, it's 100 meters.
Okay.
That's what the spec says. I haven't actually tried it because the other radio, well, actually I don't even have it connected. They're a foot apart right now on my desk.
Right. I mean, I got the ones that had the smaller antennas because I was going to be testing them, right next to each other. So I didn't really care about distance, but I've had that question before about how far away do they work.
Right.
So,
and I do have I am planning on doing the same as I'm transmitting data with an Arduino. I've got my Pi out, and I'll be showing how to send the data with a Pi as well, or at least have the code ready to show and show how we connect it up. Whether we do it live with both units, we'll see if I can get that together for next week.
Okay. So you're going to use the XPs for that too?
Yep.
Okay. So this week, you and I talked about this already this week. I ordered some of these other 2.4 gigahertz things. And here, I got one right here. Let me go. Really small, but it's 2.4 gigahertz. When I first got it, I thought it was either going to be Bluetooth or some kind of Wi-Fi, but it's not. It's its own protocol thing. So I'm going to experiment with this sometime in the next couple weeks as well. So we can, curious about distance on these two. You can see the antenna is actually on the board, so it's probably not very far.
I've got a set of these coming as well.
Yeah, so we'll see.
This is good. Yeah, and one of the viewers, I think you were copied on the. He's got sensors using these radios for his garage. And
yeah, actually, I didn't know this was one. It was the one he was using.
Yeah, this is the one he was using.
Okay,
the one he's using. So we're going to tackle that problem as well.
Yeah, that'd be a good experiment. So, yeah, I'm kind of curious how they work through walls and stuff too. That's kind of why I was asking about the XP stuff, because I got the ones that don't have the antennas on it, and I thought the ones with the antennas on it were a little farther than that. But all right.
Well, you've got the ones with the antenna on the board, correct?
Yes, a little square solder-on antenna.
All right, I've got ones coming that have a small screw-in antenna. Right.
Yeah, that's the ones I probably should have gotten, because I figured if I was sitting here at a table doing it, I wouldn't have to go very far. But then I'd like to experiment with things a little bit farther away. So I was kind of curious how far they worked.
Well, the ones with the radio on the board, I like that because you could make things that are very small and easy to hide and turn things on and off. And
right, that's the problem with the
I could see
XPs
lots of
are kind of big.
applications for those.
Yeah, the XPs are kind of big.
Yeah, the XP is kind of big,
and its spacing is not 2.54 either. It's 2.
Okay.
So you can't just plug it into a regular breadboard.
Yes, that's right. You can't.
That's why I had a board put together and made, but I don't think I ever tested it, because I didn't want to have to, custom make something every time I want something just to play with.
Right. Yeah, that is one thing about the XP that's a little disappointing.
Yeah, there's other Zigbee type chips out there. XP is just the most popular one because it's common form factor, and they make other things that fit in that same form factor as well.
Right.
So you can pretty much pull one out and put another one in if you have a generic connection to it. So you're running them in serial communication mode, right? Like what goes in one comes out the other?
Yes, that's right.
So
yeah, and I'm running it back and forth. And in one example, we will talk about the buffers in the radios and how to prevent data collisions and not overload the buffers, and write the code to be smart and be aware of the buffers.
Right. So yeah, the XPs have the ability to go into another mode, which I like to experiment with a little bit more, where you can individually address them. Because my understanding is if they're in this serial mode, they do not work in a mesh anymore.
Yeah, these two that I've got, they only talk to each other right now.
Right, but if you take them out of that mode, they can work in a mesh mode as well.
That's right, and you can also have one being the controller, and then you can have routers, and then you can have points.
Yeah,
and bounce signals back and forth between the whole.
Yeah, it was just very complicated. I mean, I tried experimenting with that a little bit, and just getting the work through serial wasn't the easiest thing to do.
Yeah, and I made sure that I grabbed the created files for the setup of the radios, because that was probably the most difficult part, is just getting the radios working.
Right, which is kind of saddening in a way, because it'd be nice to stick them in and let the Arduino do the configuration, but it doesn't work like that.
No, it does. Sadly, it isn't.
Right. I mean, it'd be nice to be able to stick one in and say, okay, here's what you are. You go do your work, and you don't have to go through the extra step. You just plop it in. Now you got to program every one of those things to use them.
Right.
Yeah, that was the frustrating part that I had whenever I was playing with them too. But mine still, if I plug them in, they just work because they're still synced together and everything. So I get them out occasionally just to play with different things. But I would like to go ahead and change that mode over now to try the routing in the controller format. The problem is I do so much on a Mac, and they don't have any software for the Mac. It only runs on a PC. So
there is a programmer out now. The what is it called? The AC. I forgot the whole name. There is a Mac. When you did episode 12, where you set up the episode, it was version 5, and it was only available for Windows. I found when I was programming mine last week, there is a version 6 and a Mac, and there is a Mac.
I'll have to go try that out because that was
now.
I was doing it in a VM. Sometimes I think that made my difficulties a little bit worse because sometimes I wouldn't see it in the serial communication. So I think that was part of it. So yeah, I have to go dig that up and play with it. That'd be cool to play with.
Yeah, the only thing about the Mac version that I didn't like, that I actually didn't get working on the Windows version, is you're supposed to be able to test the range of radios once you have them set up. And I didn't get that working on mine. And once I had it working, range, I was happy they were working, and I was trying to get the demo done. So I skipped that part.
All right. Well, it's something we look forward to for next week then.
Yep.
All right. Well, we've been doing this for 44 minutes with all kinds of technical issues before and during. So I just think we need to get it over with.
Call it a night. And
yeah.
Okay. Sounds good.
So hopefully next week I got more time ahead of time. I mean, I basically did that sketch within the last 3 hours and worked fine on the test bench. And when I got it in here, it's not working again. And I finally figured out that I was having a problem with the MAC address being duplicated on another switch. And it was just, not to mention all the broadcast problems that's been going on. So,
well, I'll have quite a few sketches and quite a few files for next week, but we won't go through them in great detail because a lot of it is topics we've covered in the past.
Okay, sounds good. So, anything on the chat room?
I've been chatting a little.
Yeah, I see that. That's good.
All right.
All right. Yeah, that's it. We'll call it a night before something else blows up on us.
Okay.
All right. We'll see y'all, everybody, next week.
Good night.
For show notes for this show, contacts, and more, go to the techzen.tv website where you can get show notes for all of our shows. We love to hear from our viewers and listeners. We have an email, a Twitter, and a phone number where you can contact us for each show. For details, visit the techzen.tv website and get the show details. You can also make a video and upload it somewhere like YouTube or Vimeo and then just send us a link. You never know, you may see your video in a future show. You can get all of our shows delivered automatically to your favorite device by going to your favorite podcast website like iTunes and subscribing. Each of our shows also has a YouTube channel you can subscribe to get regular updates. Our shows are also available on most internet radio networks like Stitcher and TuneIn Radio. You can also watch and listen to our shows on Xbox, TiVo, and Roku. You can even find us on your Zune.